Okay, so I'm torn. Can you guys hear me at the back? No? Should I talk louder?
Yell.
Fuck you. I will shine a laser pointer in your eye. The problem with the microphone is then we'll get an echo in this microphone. So, you know what? I appreciate that. So if it might be fine, close enough, I'm going to talk about the Canadian Cyber Defense Challenge and how we built it presently and the historical version of what we built. And we'll get into that. But the Canadian Cyber Defense Challenge is a not-for-profit organization that focuses on how do we make it easier for high school students to get into IT security as a career? How do we make it easy for them to understand what a day in the life of a security professional actually looks and feels like? And give them some kind of faithful representation of that. So it's not just go there and hack all the things and find all the flags and reverse engineer all the malware. There's actually a business presentation component to it. And we focus on it being at least kind of half-assed fun. I mean, it's kind of malicious. We don't like the students, so we're mean to them. But we give them an opportunity where we hope it's fun for them so they get a gamified experience. It's been running since 2012 was our first event with 8 teams. And in 2015, Jared Bader gave a talk at, let me know if I do have to move to the microphone, like legitimately. Jared Bader gave a talk at, it was then called B-Sides, awesome talk, it's on YouTube, about how they built it in 2015. And I'll get into more detail there. But basically, it was built entirely on donated hardware and VMware. They did everything there. And it worked well. It worked reasonably well. The biggest problem was that 802.11ac wasn't a thing yet. But it's run entirely by volunteers. Everything is built and operated by volunteers like myself, like Travis, like Derek, like Jared, who is not here. Ass. So if when I'm done, you have any interest in this whatsoever, hit either Travis, this guy, myself, or Derek, this guy right here. Yeah, you opened your eyes too soon. But we're happy to get you involved. Because really, realistically speaking, volunteers are our most limited resource, and it is so hard to come up with challenges that high school students don't screw up. So, wow, my speaker notes are tiny. I can't read that. Fuck off. Okay, so apparently that's all I'm saying about that. So, story time. The evolution of the Canadian Cyber Defense Challenge, it looks something kind of like this. So in 2011, we had the idea, we ran the first event, we had 8 teams, it was all super great. In 2015, we got a bunch of hardware donated. We used Merlin's networking. Thank you, Merlin. You weren't there. We used Damon Defense contributed a bunch of compute gear. We had some storage donated directly by Dell. We did some really clever things to make 10 teams work on that gear. And in 2016, we did pretty much the same thing, but with a bit more automation. In 2017, the Jenga tower of sadness fell finally, and the people weren't available. And I'll get more into that later, but we had to fundamentally re-architect. And it was that point where Jared calls me and says, hey, Mike, so you busy for the next 3 weeks? And I said, yeah, Jared, I'm busy for the next 3 weeks. He says, can you clear your schedule? Because I need help. And at that point, we went, great, we have to fundamentally re-architect. We can't do it in what we've got. We can't do it in borrowed gear. We need to grow up and own our own shit. As much as you own your own shit in Amazon. So 2017, 24 teams, 2 provinces, and it was a big jump. Like we outgrew the hardware we had. We would have needed twice as much donated gear. Like you just don't find extra donated gear that like kicking around like that. 2018, same deal. Like we added more automation, and in 2019, everything just got a big overhaul. So the architecture in 2015, this is a picture of actually my dad's car. Great for the time it was at. Right, and that's the key thing, is great for the time it was at. It was built on the ESXi, borrowed and donated hardware, all wired networking because wireless was just trash in 2015. We didn't have AC yet, so everyone was sad. And not only that, but we couldn't go into something like the convention center or Red River or U of M and start screwing around with their RF spectrum. Like, they had a site survey. It was done a particular way. We go in with our own APs just to increase density. They will hunt us down without prejudice because wireless was not good enough to let people just come in and do their own thing. And they had enough small enough teams that they could do this thing kind of on their own. And for context, a team is 4 or 5 high school students that come in with their own tragedies, bring your own disaster. They show up with their own laptop. We've had some teams show up with iPads or Surface Pros. So one team showed up with no laptop one year, and we're like, how did you expect to do this? So we don't control what teams get, and there's an asterisk there, but it's a really small one. So they show up with whatever they want, and we have to somehow allow them access to our target environments in a way that is functional for them. So I'll talk about how we did it and then how we now do it and why we chose to make that change. But the architecture in 2015 was really good for what it was. 2015. There were some fundamental limitations. It was not geographically scalable. So the other province we had was in Vancouver. So what we did is we shipped switches that Jared pre-configured and prayed to God, sacrificed I don't know how many goats to make sure those switches worked when they just powered on and were plugged in. That was how we did the Vancouver site in 2015. We shipped them networking gear so they could call home and have wired networking at the event site in Vancouver. It was not team count scalable. Like, it's donated gear. If we went from 10 to 30 teams, we would need 3 times as much donated gear. And as much as Dell loved us at the time, they probably didn't love us that much. Like they had a main piece. We were kind of like the side piece. Like they didn't love us that much. Automation tooling was hard with free VMware ESXi. You don't have all the same tools you have with actual vCenter. Like it's a different environment and it's harder to automate. And licensing was gray. We'll say it was gray, maybe a dark gray, like the color of my vest. And Jared and Chris talk about this in the B-Sides talk, which is on YouTube, but it's things like with the Windows 98 VM in the environment, how do you license that when it's out of support? Like if you want to provide it, how do you do that? If you want to provide a Cisco target for all the teams, how do you do that in a way? They used trial licenses for everything. And while that kind of worked fine, those spend relationship bucks. You spend relationship bucks with your partners, with Microsoft, with Cisco, they used OpenVPN Access Server for VPN access. Those are not sustainable models. So there were some fundamental issues with how they built it. So 2017, the Jenga Tower falls. The Jenga Tower of sadness falls because people have day jobs and they're busy, and because the gear from 2016 is insufficient, and we have too many teams to run on it. And the tooling scripts are no longer available because apparently Git wasn't a thing in 2015. And GitHub wasn't a thing in 2015. And they were thoroughly boned with 2 weeks to go. That's how I got a phone call at 8:30 at night on a Sunday. So enter our savior, the cloud, because the cloud is great. For those not familiar, these are apparently the new, all the AWS icons you see, these are all of the new icons. They're different. I don't like change. So this is a whole new thing for me, and I'm not a fan because they're so foreign. The skeleton of the architecture they had was really good. The architecture had legs. So you could, the fundamental principles were there. 802.11ac was brand new and deployed, thank God, in all major environments. Convention Center, Red River, U of M, they had all deployed 802.11ac, which is important because it was as good as wired, right? Like you could actually go into an environment and trust that the wireless is not going to just flake out on you, which was the big reason they used wired networking at all the previous events. So my skills are in Amazon. If I'd known, if VMware had had these tools, they probably wouldn't even have talked to me. They would have gone with what they knew, VMware. I knew Amazon. They went, hey, Mike can do this. We have $1,000. We can pay Amazon, right? And it turns out the answer is yes. But Amazon was not a choice made out of any particular intent, only because of available skill set, right? It was built on VMware and Windows Server and Cisco because that was the skill set of the original team. So couch everything I'm about to say in the fact that I do AWS, I don't do Azure, and we didn't evaluate all the options. We just did the one that we knew because we had 2 weeks and we're very much under the thumb screws. So these are all of the services required to make the game day event a thing. This is, give or take, every single AWS service that we use that is required to make the game day event a thing. I don't recognize a single one of these. This makes me uncomfortable. I don't like it. I was this close to using the old icons, but I'm like, you know what? I should get used to this. But it's things like EC2, EBS, CloudFront, API Gateway, Lambda, DynamoDB, RDS, load balancing. All of this stuff is required to make the event a thing. And all of these things, we couldn't have done it if any one piece of this was missing, we would have had to change our architecture. So it was a cloud native design from the get-go. There's no way to get around the fact that this wasn't a port of an on-prem architecture up and just drop it in Amazon. This was a fundamental re-architecture using the tools available to us. And when you do that, you end up with this. You end up leveraging the giant ecosystem that's available to us. So the rest of this talk is going to be the fun part, where I talk about how we actually architect the new version. It's going to kind of skim through tread water at the top, but there'll be some deep dives into the parts where we encountered and were bit by nuances in Amazon's platform because we were doing something interesting. So the basic student experience we wanted to enable. They show up, they connect to the Event Center Wi-Fi. We don't know where that is, a priori. So keep in mind, I'm going from a talk about DevOps, this guy right here, a talk about DevOps, to an application that's deployed exactly twice per year. Right? Continuous deployment, twice per year. So this is one of those things where, and in 2019, we borrowed 700 cores, 400 VMs, 2 terabytes of RAM, and 3.3 million IOPS. It had to work, but it had to work for 12 hours. And then we ripped it all down. So the reliability, repeatability, testing of stacks and small scales, because you can't just sort of test stand up 400 VMs. That takes some amount of time. It's automated, and because that was one of the core tenets, I'm not doing this by hand. Fuck, I got better things to do. So this is the student experience we want to enable twice per year. That's sort of the difference in talks. They show up, they log in, and they'll say here, they log in with VPN to their team's targets, to their resources, whatever it is. They configure their VPN client to access the thing, and then they hack away for 6-ish hours, and then they see their scores updated, and they go home. Probably having lost, but a couple of them will win, and that's just kind of how it goes. And so this is where it got really interesting. The biggest change that Amazon let us have is we weren't on the wrong side of licensing anymore. We knew for a fact we were above board on licensing, which, because we're now at a point where this is a big event. We're tied in with, at that point, WCISC and ISACA and national conferences and national sponsors and large sponsors like Palo Alto and Cisco. And we have enough things here where we can't be on the gray side of legality anymore. So one of the biggest structural things from an organization standpoint that Amazon gave us is being on the right side of licensing. It sounds like a weird, red tape bureaucratic piece of garbage, but it was an important thing for us. Marketplace gave us Cisco. We just rent Cisco CSRs, cloud service routers. We just rent them by the hour. Now they're 60% of our cost and they come out of pocket. All the rest of our costs come out of credits, but at least we get them and we don't have to screw around with Cisco trial licenses. I tried, it's a nightmare, don't ever try it. Oops, wrong button. And Windows instances, like these Windows licenses just come out of credits for us. Previously, we were like, how do we get a Windows license for 8 hours starting 4 hours from now? I don't know. Okay, well, just stand it up, see what happens. Now, like it removes it from the organizational mindset. We don't have to think about it. We just pay for it. That was a really important part of what Amazon gave us, is that this is not something we worry about. That's not something we worry about coming back to bite us. So I wanted to call that one out specifically. So architecting the Warzone, there are some fundamental tenets. Students shouldn't be able to screw around with another student's stuff. Specifically, one student should not be able to affect another team's experience. Right? Like you shouldn't be able to hit each other's targets. You shouldn't be able to screw around with each other's laptops. Like it shouldn't be a thing. And deployment is automated because from day one, I ain't doing this by hand. At this point, I'm starting with 25 teams, and I'm imagining a situation where the Canadian Cyber Defense Challenge is coast to coast. Like I'm not hand bombing 500 stacks. And the big problem with VMware is, while you can rubber stamp VMs, they are rubber stamps. They're identical in every single way. And I've had very weird networking conversations, and I'm sad Jared's not here, about him asking me, how do I do networking where every single subnet has the same addressing scheme and the same subnet, and the same CIDR block, and the same routing policy, and the same firewall rules, and everything is the same, but I want them to be different? I'm like, Jared, I think you're asking the wrong question, because I'm not drunk enough for this. But like that was it, is they would rubber stamp everything and then go in and hand tweak every single VM because they weren't identical. They were actually a little bit different. So that was, as much as they could automate, there were certain things that they simply couldn't. And that was the big part of what we wanted to change. So the automation design it's a two-stage deployment. It's not three-phase power, but it is a two-stage deployment. There's a Python script that drives CloudFormation. And the thinking there is the Python script does non-trivial processing, things like subnet calculations, things like stuffing objects in S3, things like generating UUIDs, things like generating SSH private keys. EC2 key pairs are not a CloudFormationable resource. You can reference them in your EC2 instances and whatnot, but you can't create them in CloudFormation. And I didn't want to just hand off to a bunch of Lambda functions, and I'll get into that, creating EC2 key pairs, because I might want to reuse them. I might want to have to pull them out. So it takes care of a whole bunch of non-trivial processing, and then feeds all of those inputs to CloudFormation templates. So all those templates are given things like they share a VPC, right? If we have 50 teams, we can't have 50 VPCs. It doesn't even semantically make sense. So they share a VPC. That's an input to the Python script. We have some Docker containers that are artifacts and tasks and targets in the environment. So those ECS task descriptions are predefined, and then the name is fed into the Python script, and that's passed to the stacks. So there's a few of these things that are sort of pre-baked, shared portions of the environment, but then every stack is a team's stack. And that's where we get into the big part, like the obvious part. How do you prevent teams from screwing with each other? And fundamentally, if you've done it before, how do you prevent computer A from screwing with computer B? Firewall. Okay. What part of a firewall? Like a firewall rule, right? How do you do a firewall rule? What set of steps would you do to make a firewall rule?
Network ACL.
Sure. You'd log into a router, or you'd log into a switch, and you'd update the config, and you'd add a firewall rule or an ACL rule to your existing rule set. Maybe you renumber them, but you log into an existing asset and you update a configuration. That's how traditionally you think of security controls, is a thing you modify the state of to enact the policy you want. Amazon and public cloud in general is very different, because security controls are first-party citizens of the platform. I don't ask for a firewall rule to be created on some router. I just say, create me a network ACL rule. Create me a security group rule. These are first-party things. So when we want to enact the policy of Team A can't fuck around with Team B, we just create, as part of the CloudFormation stacks, all of the necessary security controls as first-party citizens in the stack resource set. Again, that's a fundamental change in how you think about things, because no longer do you have to have an existing resource to modify, you just create the policy control you want. That's very enterprisey speak for don't update a router, just create the rule. So as part of the CloudFormation stack, all the rules, all the security groups, everything is baked into there. So there's nothing pre-existing. The VPC is literally blank. There's nothing in the VPC when we start. Everything is spawned by these CloudFormation stacks. And they control their own access. Because the Python driver script gives them, here's the subnet that your team is going to be coming from, just block everything else. And do this and do that. And that's how it works. So the target stack design is not super interesting, but I'll go through it. There's stock AMIs. So coming back to what we heard about is version control your stuff. We use stock AMIs for everything, and all the customization is built on user data. So we don't build golden AMIs. We don't build golden images. That's just too much of a pain in my ass, and no one else does this part of the CCDC, so I don't want to do that. But this also allows us sort of accidentally to be able to make sure that nothing's out of scope. When we deploy artifacts, we know exactly what we're deploying to a base image, and because we want this to feel as real and faithful as possible, we make sure that nothing's out of scope. We use Systems Manager, but it's not out of scope. If you want to go and screw around with it, all it does is means that okay, now it's time for me to talk about Better Dave. You remember what I'm talking about, right? All right, so have you figured it out yet? All right, this is going to be a fun reliving tale for you. So in 2019, end of April, we had our event, and we had 33 teams, one of which was from Ontario. They were in the CBC, they were in the newspaper for placing nationally recognized in Cyber Patriot? Cyber Titan? One of the two. Like a national security event thing. Awesome. So we poached them and said, hey, you should sign up. And they were our first team, and they brought another team from their school from Ontario. We spanned 4 provinces. That was awesome. So about 2 hours into the event, they really haven't scored any points, and now suddenly they can't access one of their jump boxes. We'll get into that a bit later, but it's they can't access one of the VMs we gave them to access their environment. Okay, all right. Why can't you access it? Well, we keep getting credential denied errors. Okay, all right, well, I'll hop in and take a look. Jump into Systems Manager, I can still shell into it through there, they haven't killed that, super handy. So I start poking around and going, all right, well, I'll just reset the password for the administrator user. We give them they just leave the default administrator user open, and we give them the password. So I'll just reset the password to what we gave them, and then they should be able to log in. So I try that, and it errors out saying user not found. Interesting, the default administrator user is not found on a Windows box. That's like going root user not found on Linux. Interesting. So I start nosing around a bit more, and they had renamed the default administrator user to Better Dave. And I can fathom no reason why, but these are the kinds of things that we deal with where students just do a thing in the middle of a game day to an out-of-scope resource. So at this point, those jump boxes were out of scope. You break them, I'm not re-provisioning them. They're in spot. Like, I'm just not reallocating them for you. And that was made very clear. So students will do very weird things throughout the day. So we use Systems Manager to jump in, but it's still not out of scope. It's still not protected because we can re-provision their targets as required. And the networking, we use network-based scanning for all of our blue team flags. So the Windows server they get, port 135, 139, and 445 are all open. We have to explicitly open those because the default Windows Server AMI is too secure for our use case. It shows up out of the box with all the necessary ports closed except for 3389, which is what you expect. Only RDP open, everything else shut off. So we have to open those up, and then they have to go close them and whatnot. But we use network scanning to probe them so that we don't need an agent to tell us when they've done the thing right. because they could close by shutting off a service, they could close by changing firewall rules, they could create a new firewall rule that's a deny rule if they want. Like there are all sorts of ways they could achieve the right outcome, and I don't care how they do it. All I care about is that they do it. So that's the key to not having things out of scope. So the flag artifact design is interesting. How we get flags onto the targets is, again, all through user data. We don't pre-bake AMIs.
Explain what flags are.
Okay, so flags are any way to get points. Thank you. The flags in our environment are any way to get points. Some of them are red team, here's a binary file, you have to run strings on it, and you have to get this. They're all flag colon and then the flag string. So it's easy to find if you know the format, and the students do. So you have to run strings on this binary. You have to right-click. There's a flag in the ID3 info for this MP3 file. So those are the kinds of artifacts we have to deploy to these target instances, and it's all done through user data. The trick is, user data exists, like the script exists in the logs on Windows Analytics. The script itself exists verbatim in multiple places on the root volume for these instances. So we can't have all the detailed deployment steps in the user data script, because then it would be an open book. Like they could just go and find that and then read that and then get all the points. And that's no fun for me, because I can't torture them. So we create unprivileged user data, which just goes and fetches the real script from S3, which is publicly readable, but it's all UUIDs, so whatever. So then that script goes and fetches the actual artifacts themselves from S3. And then it goes and does configuration, like inserts, bookmarks, copies MP3 files, renames, whatever. We have a respawning root backdoor that shows up, so creates scheduled tasks or cron jobs for that. So that's what this deploy artifact does. And then it burns the real script from S3, just using HTTP delete. So it's an unauthenticated, just HTTP delete, just burn this S3 object, and then leaves no trace on the local machine. So if the students are smart enough, and none of them are, let's be honest, to go and find the user data script and find all the logs, even if they went to go and try and collect that particular script, like the real one, they wouldn't be there. So they couldn't see what was done. So that's how artifacts are deployed, given the condition that, again, running into the nuance that user data exists, and if you need it to be private, it's not. So if that is a use case you happen to have, it's pretty oddball. But just note, user data kicks around for indefinitely. Okay. Turns out OpenVPN is really, really hard. Who's used OpenVPN before? Who loves OpenVPN? Get out. Right. OpenVPN was really, really hard, especially for the students. And it would be sometimes hours, 2 to 3 hours right before lunch for all the teams would actually even be connected to their targets. And that's unacceptable. The more time the students have to hack away at the challenges, the better it is for everyone. So in 2019, this year, we gutted and replaced OpenVPN with straight up RDP, which turns out you can do from the Event Center Wi-Fi. It's just 3389, just out you go, have fun. So we used that, and we built a bunch of jump boxes based on FireEye's Commando VM. Super slick project. You found it? Yeah, so Travis found it, and thank God you did, because this has been a challenge that's plagued us for years, is how do we provide a set of tools? Commando VM is basically Kali, but Windows. So it's a Windows VM, so you start up a bare Windows VM and just run their script. It does everything for you. Super slick, really awesome. We customized it a bit, made it a bit easier for students to use, but that was what we used for jump boxes. And we stood up 5 per team, and running them in Spot saved us a boatload of money. Not as much as it used to, only 75%, not 90%, because of the new pricing model, but it saved us a ton of money and gave us a far more reliable, lower barrier to entry way for students to access their resources. That was the biggest change we made. And this is the first out of scope element, and I think I need to be better and put it on the background. This is out of scope, because the number of times we had students changing the passwords to their jump boxes, assuming they were in scope. It's like, okay, so I'm gonna have to go fix that for you because you changed the password and didn't remember what you changed it to. So the CloudFormation template that we stand up is interesting because it uses a bunch of magic a little bit, things that are, well, reasonably fine. Oh, good. Okay, good. My microphone's still here. And custom resources are used all over the place. So who's used CloudFormation? Who's used CloudFormation custom resource? Cool. So CloudFormation custom resources are essentially you can write a Lambda function in your CloudFormation template and then tell CloudFormation that, oh hey, this resource is type custom resource, and it's actually this Lambda function called with a particular set of parameters. So it allows you to do things like create an EC2 key pair in your CloudFormation template when actually EC2 key pairs are not supported in CloudFormation. It allows us to create a particular kind of EC2 spot instance that CloudFormation doesn't support without additional scripting. It's all baked into the CloudFormation template, and it's really useful because it allows you to scab fix in either new services that Amazon releases and the CloudFormation team is late to adopt, things that they just fucking never friggin' support, like origin access identities for CloudFront. I swear to God, that one has bit me multiple times. But there's a bunch of stuff where you just can't do or can't do yet. And custom resources are a phenomenal way to do it. You do Terraform. Does Terraform have a similar concept? All right, so we got some hand wavy stuff. You could probably scab it in, but custom resources are basically Amazon saying, we recognize this isn't perfect. Here's the mechanism we give you to Band-Aid fix whatever you need. So we use those all over the place because what we do is apparently weird. And there's several dozen different resources contained in the template. This predates things like stack sets. This predates things like cross-region stuff. This architecture predates a lot of the quality of life improvements Amazon's released, and I just do not have the fucks to update it, basically. It works well enough. Stack sets would be nice. Detecting drift would be nice. We don't support any of that because it was built before all those were features, but they would be important quality of life improvements down the line. So the future, and I'm going to shut up real soon. I want to our plan is to open source this whole thing eventually, but right now it's too tied in with our actual targets and artifacts themselves for us to do that without revealing too much information. But hopefully for 2020, we'll have a nice separation between the infrastructure that this stuff runs on and how you build the artifacts and the artifacts themselves. So open source the first two. Our artifacts will stay ours unless you're going to run a version of our event. But it would be really nice to be able to say, here's the architecture. Nonprofit in Africa. You want to go run an event to try to build cybersecurity in your community? Here's the thing. Like it costs us, I think it cost us $800 to run an event for 170 students. Like that's not bad. Like that's 800 Canadian pesos, not American doubloons or whatever it is. All right, so like that's not bad, and that's within the realm of a crowd-funded or community-supported organization. So the goal is to take all this work and open source it. Support flexible VM sets. Currently the stacks clearly, very explicitly define, here's what the targets are, here's how they're configured, go. But it'd be really nice to be able to say, I want these artifacts, and then build my template from that. So that what you have is an artifact or a flag-driven environment. So I say, I want these 24 artifacts in my environments, build my template for me, and then launch my template. That's what I want to get to. Maybe not this year, depends how much time I have. More Docker. Docker is great for stateless artifacts. We use it for websites and other just straight up TCP listeners. And we're looking at doing more integration with our story, or at least provide options for more integration with story. So mini games for like chocobo racing and all those other mini games we love and we know and love. Not covered. That is some tiny text. I have not covered the website or the scorecard, which are fundamental parts of how teams actually get points. So this one's actually fully open source. There at that link you very conveniently can't read. I'm going to skip right over that one. And now we have the fun part. Is there time for questions, or do I have to get off the stage? That'd be really awesome. Ah, shit. Okay.
Has there been any thought of having a couple of targets always up for training of potential teams to get a feel for when they might be counter eventing?
That's come up a lot. The big problem is our challenge library isn't big enough for us to keep challenges up all year and not have it give away important elements of the thing. As it is, we hold an event in January tied to BC's BC Aware event. Those teams always have a marked early game advantage in the May event. Just because the games are so similar, our challenge libraries aren't big enough yet. But yes, absolutely. We're funded by Amazon credits as a nonprofit. So using this, yeah, you can just keep a couple of stacks running. Don't run the CSRs. They cost money, like a non-trivial amount, like 60 cents an hour for the smallest one. But yeah, it's come up a bunch. The bottleneck is challenge library.
So for now, I guess just point people to Hack the Box, HSCTF, things like that today.
Pico CTF, yeah, all those sorts of things is we provide resources to the teachers because these students are usually coming out of an IT security program at their high school. So we provide resources to teachers, we provide resources to students. There's a resources page on the website where we basically send people and say, you should know a bunch of this, okay? Have fun, bye, and then we run away. So it's very hands-off on our part. We should do better, but we're just not resourced for it for a variety of reasons. Yeah. Really? Nothing? Was it that good or that bad? I see lots of thumbs down. Okay. Well, if you have any questions or if you have any interest in contributing, Derek, Travis, or myself, hit us up. Amazon makes it easy, but we still need people. Like that's by far our most restrictive resource. So yeah, come have a chat. Okay. Thank you.